Welcome back to my YouTube channel. Thanks for watching. So today we're going to talk about Phasor. Phasor in engineering, basic electrical engineering. So the definition: a phasor is a complex number that represents the amplitude and phase of a sinusoid. That is, it represents the amplitude and phase of a sinusoid. If you don't know what amplitude, phase, or sinusoid is, I will put the link of our video that will put the definition there in the description. But a sinusoid is a signal that has the form of sine or cosine function. So the next thing is that a complex number z can be written in a rectangular form. When I talk about complex number, we have some two major forms that we're going to be talking about: rectangular form and polar form. In rectangular form, the z it can be represented, it will be equal to s plus jy, where our j is equal to square root of -1, while the s is the real part of z and the y is the imaginary part. The second one is in polar form. The z in polar form or exponential form. The polar form can be written as arrow into this file. This arrow is the magnitude, while this file is the phase, that is the phase angle. So this is the rectangular form. So this one here is the rectangular form, while this is the polar form. These two are the major things we're going to talk about. These two. So the next thing we're going to talk about is like the conversion. How do you convert from phasor, from polar form to rectangular form, or from rectangular form to polar form? The conversion. So to convert from rectangular form to polar form, so that is our s will be known and our y will be known. That is, we have the value of s and the value of y. So we're going to look for this in polar form. We want to convert from this form to this form. All these s and y, they are known. So we need to look for r and file. So to get our r is the square root of s squared plus y squared, s squared plus y squared. So if you do the value, you get your r. And to get this phase is the tan inverse of y over s. Tan inverse of y over s, not y square or s square. Tan inverse of y over s. Then for us to convert from polar to rectangular, that is our y, our r, and our phase, that is magnitude and the phase, they are known. We have the value. So by having the value, we are going to try to get our. So since our r and our phase is known, we're going to try to get our value for s and value for y. So this is the general formula to get the both at the same time. Is that equal to r bracket cos phi plus j sin phi. You close the bracket. So this cos represents the s, y the sin represents the y. So you can still write it like this, that your s is equal to cos phi, y is equal to sin phi. So r cos phi and the r sin phi. So we kind of bring the two of them together. That's why we have it in this form. We bring the two of them together. So this is how to convert from polar to rectangular, and from rectangular to polar. So you may be asking the question that in what situation do we need them to calculate to convert from polar to rectangular or from rectangular to polar? So this is how we need them. If I have to add complex number together or to subtract, we have to do it in rectangular because it is better performed. Addition and subtraction of complex number, they are better performed in rectangular form, while the multiplication and division are better done in polar form. That is, if they ask you to multiply or divide, you will do it in polar form, and if I to add or subtract, it's in rectangular form. So given this complex number, z is equal to s plus jy equal r into 5. Z1, we have to take note of this thing very well to get some things. Z1 equal s1 plus j1 equal to r1 plus phi 1. Same thing here. So if I to add, we are going to add in rectangular form. That is, if that's to write z1 plus z2, we're not going to use this and this. This is what we're going to use because it is better to perform your addition in rectangular form. That is this plus this. So it will be, you take the s, it will be, you open your bracket, s1 plus s2, this one, close the bracket, plus this one. This j is common to both of them, so it will be j into y1, this y, plus y2, close the bracket. Then subtract again. It's still going to perform in rectangular form. Z1 minus Z2 equal, open bracket, S1 minus, because we are doing minus, S2, this one. Then we add them to again, plus J, open bracket, Y1 minus Y2. Then we close the bracket. That is addition and subtraction. But to multiply and division, Z1 times Z2, we're not going to use this rectangular form. We're using the polar form. So it will be r1 times r2 to get our r. Then to multiply the angle, we are not going to multiply it, we will add the angle together. You multiply the magnitude, then add the angle together. Then in division, z1 divided by z2, we are going to divide the magnitude, that is r1 and r2. Then we are going to minus the angle, that is this one minus this one, that is to minus the angle. Then if you are looking for the reciprocal is 1 over z. 1 over z is equal to 1 over r. Then we put minus to the angle. Then the last one that we are going to do there is the square root. Square root of z is equal to, look for the square root of r. When you get the square root of r, the next one is you divide the angle by 2. While the last one is complex conjugate. Z is equal to s minus jy equal to r minus the angle equal to r exponential minus j, just to power minus j, and the angle. So that is like the basis of Phasor. You can go through this again. It is actually very simple. When you know, if you can know all this, how to convert, how to add, how to multiply, it's very simple. And then in our next class, we're going to be solving question. We're going to try to solve question on Phasor. Then after, I'm going to teach you how to use calculator to solve it, in case you forgot something or not in the exam. So thanks for watching. Please come back, like, subscribe. Thanks.